In this video, I will discuss a telescoping series. In mathematics, a telescoping series is a series whose partial sums eventually only have a fixed number of terms after cancellation. The whole cancellation technique, with one part of each term being cancelled with the other part of the next term, is also known as a method of differences. Okay? That means, please note that telescoping series could have a different name, and we call method of differences. And let's see my first example. That means we can see, let's exercise number 1. Determine whether the series is convergent or divergent. If it is convergent, find its sum. And the formula is as follows: summation from 1 to infinity, and it's 1 over n minus 1 over n plus 1. That means, seeing this difference, this is one of the ways to recognize that this is possibly a telescoping series, because we see the difference between two consecutive terms, 1 over n, and the next one is 1 over n plus 1. Okay? That means probably will be easy to find a partial sum and check how this partial sum behaves at infinity. That means let's try to do it. I will name the partial sum maybe as sub k. Okay? And this will be defined as a summation starting from I equals to 1, ending with k. And the formula is 1 over I minus 1 over I plus 1. Okay? And then I will expand this and try to check if I can really cancel one term, part of one term with the part of the other term. Okay. Substituting instead of I1, I will get the first term 1 and 1 plus 1, 2. Okay, that means this is the term that I equals to 1. And now I have another term with I equals to 2, I equals to 3. Actually, I can have a little bit more. I equals to 4. And then okay, and now I will say this will be I equals to 2, I equals to 3, I equals to 4, and then I am making a small gap, and then the last term will be with I equals to k. One before that will be I equals to k minus 1 and k minus 2, and so on, of course, going backwards. Okay, that means let's fill out the terms. If I is 2, I have 1 over 2 minus 1 over 3. If I is 3, 1 over 3 minus 1 over 4. If I is 4, 1 over 4 minus 1 over 5. And now let's start from the last term, 1 over k minus 1 over k plus 1. Now, instead of I'm substituting k minus 1. K minus 1 plus 1 is just k. Now, instead of I will put k minus 2. K minus 2 plus 1 is k minus 1. Okay, that means let's see what's happened. As I said, it's a method of difference, and I can simplify lots of terms. We can see part of the terms. I do have negative 1/2, and in the next term I have positive half. That means negative and positive, and then negative 1/3, positive 1/3, negative 1/4, positive 1/4. And of course, if I will have another term listed, I will also cancel this one with my next term. And let's see from the back side. I have negative 1 over k and positive 1 over k. I have negative 1 over k minus 1 and the positive 1 over k minus 1. And I will also have this one cancelled with something if I will list more terms. But what's happened? I will never cancel the first term. We can see this, and I will never cancel the last one. That means this is my last. I mean the second part of the last term and the first part of the first term. Okay? That means I can say that all of the terms are gone except 1 minus 1 over k plus 1. That means this is my partial sum, okay, S sub k, and finding a sum, I have to find the behavior of the partial sum at infinity. That means the partial sum is defined as a 1 minus k plus 1, right? This is the partial sum. One more time. And we can see 1 over k. K is a huge number. That means 1 over huge number is 0. 1 minus 0, of course, is 1. That means the sum is 1. This telescoping series is convergent to 1. Okay, that means this is nice method of difference. I have one more comment before I start the next exercise. Having this formula, please also note that we may see this formula in terms of the rational, like written in terms of the rational function. That means I can have 1 over n times n plus 1. That means you can still see eventually like 2 consecutive terms, n and n plus 1. We're not adding or subtracting them, but we still have to think that we may broken up into the partial fraction. That means if you will rewrite this as a partial fractions, you will actually get this difference of 2 consecutive terms. That means even having this, please always note like n and n plus 1, it should be for you the sign that you may rewrite this and eventually having a difference and using a method of difference. Exercise number 2. Determine whether the series summation from 1 to infinity natural log of the quantity n over n plus 2 is convergent or divergent. If it is convergent, find its sum. And we have multiple choice option. The sum could be 0, ln of 2, ln of 3, ln of 1/3, or the series is divergent. Okay, that means again, I don't really see the difference between 2 consecutive terms. However, I see like n and n plus 2, which they are not consecutive terms, but they are still terms that came from like one sequence, n plus 2. And I also know that the logarithmic function, I can rewrite as a difference. That means let's rewrite the given series as a natural log of n minus the natural log of n plus 2. Okay? That means n and n plus 2, ln of n, ln of n plus 2. That means they are terms from the same sequence. That means I'm assuming that this is a telescoping series. And I have a difference. That means I will use my method of difference and I will try to cancel out terms and get the finite number of terms for the partial sum. And we will see how this partial sum behaves at infinity. The partial sum will be defined as a summation of the finite number I starting from 1, ending at k, and it's ln of I minus ln of I plus 2. Okay, and let's start. That means I will list the term with I equals to 1, I equals to 2, 3, 4, maybe 5, and then I will make a gap, and I will also list a few terms on the back side, maybe just 4. Okay, that means my first bracket will be defined for I1, I2, 3, 4, 5, and then let's start from the back side. K, K minus 1, K minus 2, K minus 3, and let's stop. Okay, ln of 1, ln of 3, because it's 1 plus 2. ln of 2 minus ln of 4. ln of 3, ln of 5, ln of 4 minus ln of 6, ln of 5 minus ln of 7. And then let's start from the back side. ln of k minus ln of k plus 2. ln of k minus 1 minus ln of k, k minus 1 plus 2 is k plus 1. ln of k minus 2 minus ln k minus 2 plus 2 is actually just k. And then ln of k minus 3 minus ln of k minus 3 plus 2 is just k minus 1. Okay, and let's see what terms we can cancel out. I see ln of 1 and I see ln of 3, negative ln of 3. In my next term, I see ln of 2, ln of 4, positive, negative, and I have nothing to cancel out. Because we are skipping, we can see it's ln of n, and then it's the two terms in front, ln of n plus 2. That means probably I will be canceling the terms every other term. And that's what I have. I have negative ln of 3, positive ln of 3. I have negative ln of 4, and I have positive ln of 4. I have negative ln of 5, positive ln of 5. That means what's happened? I did cancel out two terms, and my negative ln of 6 will be definitely cancelled with something if I will list more terms. And the same negative ln of 7 will be cancelled with something like the other term if I will list this term. But we can see what's happened. I still did just the half. I didn't cancel the first number from the first term, and I didn't cancel the first number from the second term. All of the other terms are cancelled. Let's see if the same pattern is happening from the back side. Negative ln of k plus 2, and I don't have that term. ln of k, and I do have negative ln of k. And negative ln of k plus 1, I don't have that term, but I have positive ln of k minus 1 and negative ln of k minus 1. Okay? And then I think I will list one more just to show you that I can cancel two terms. That means let's just add one term, which will be defined for I, k minus 4. That means we will have ln of k minus 4, and then minus ln of k minus 4 plus 2 is k minus 2, which I would like to see. Okay, positive and negative. That means what's happened. This is the term that I cancel both of the items. This means that the rest of them going inside, going backwards, will be also cancelled. That means this will be cancelled if I will list more terms, and this one will be cancelled if I will list more terms. Okay? Because this is telling me that I cancelled everything. But what's happened? The same pattern, actually, it's visible from the back side. I didn't cancel the last term, which last item from the last term. which actually kind of corresponds to the first item in the first term. And I also didn't cancel the second term. I didn't cancel the second term in the second term from the backside. And it's the same like this one, the first item in the second term. That we can see 1, the 2, the second number is cancelled. That means 1, 2, 3. 1 and 3 is not cancelled. Counting from the backside, 1, 2, 3, 4, 5, and so on. 1 and 3 is not cancelled. Okay, that means one more time. One item and the third item is not cancelled if I look from the backside. If I look from this side, 1, 2, 3. The first item is not cancelled and the third item is not cancelled. We can see it's kind of like similar pattern. I would say identical pattern. That's actually the telescoping. If we know the kaleidoscope, it's something like this. Okay, that means the green circles actually are the formula for the partial sum. That means the partial sum S sub k is defined as a ln of 1 plus ln of 2 minus ln of k plus 1 and minus ln of k plus 2. Okay? That means I did copy the green circles. And now I have to find a limit of the partial sum as k goes to the infinity. And this will be my entire sum. And I will not copy this, I will just look at this. ln of 1, of course, is 0. ln of 2 is a number less than 1. And then if k is infinity, ln at infinity actually is infinity, right? Because function, the logarithmic function, is increasing function. That means this will go to infinity and this will also go to the infinity. That means what we have? We actually have not finite number, we have infinity. This infinite series, telescoping series, is divergent. Okay, it's divergent. But one more time, it's important to note that that was the partial sum, S sub k. Okay, let's do another one. Determine whether the series is convergent or divergent. It is, if it is convergent, find its sum. And the summation is from 0 to infinity. Yeah, please note that difference. And it's inverse tangent of n plus 2 minus inverse tangent of n. Again, we see the difference. That means it's easy to recognize that it's a telescoping one. And I see like terms, almost consecutive, every other term actually, n plus 2. Okay, that means let's find the partial sum, summation from I equals to 0 to k, finite number of terms, and inverse tangent of I plus 2 minus inverse tangent of I. And that means let's see. I will list a few terms. I will list, I can maybe write it, inverse tangent of, if I is 0, this will be 2, and if I is 0, it's just 0. Then if I is 1, this will be 1 plus 2, 3, minus inverse tangent at 1. Okay. Maybe 5 terms, and then I will skip, and this will be 1, 2, 3, 4, and maybe one more, just to see the terms being cancelled. That means this is defined at 0, this is defined at I1, 2, 3, and 4. And then starting from the back side, k, and then one number less, k minus 2, 2 numbers less, 3 numbers less, and 4 numberless. Okay, let's substitute. This will be inverse tangent at 2 minus inverse tangent at, not at 2, 2 plus 1, 3, and 2. 2 plus 2, 4, because I have to see every other term. Okay, another term, inverse tangent at 5 minus inverse tangent at 3. If 4 is placed instead of I have inverse tangent at 6 minus inverse tangent at 4. And then start from the back side. Inverse tangent at k plus 2 minus inverse tangent at k. Inverse tangent at k minus 1 plus 2 is k plus 1 minus inverse tangent at k minus 1. All right, it's time consuming, but we have to list this term. Now, inverse tangent at k minus 2 plus 2 is just k, and then inverse tangent at k minus 2. Minus 2, okay? Now, inverse tangent at k minus 3 plus 2 is k minus inverse tangent at just k minus 3. One more. Inverse tangent at k minus 4 plus 2, k minus 2, minus inverse tangent at k minus 4. K minus 4. Okay, let's see what we can cancel out. It's similar situation than the previous one because we do have every other term. That means what I see positive inverse tangent at 2 and negative. I see positive inverse tangent at 3 and negative. And I see positive inverse tangent at 4 and negative. Of course, every other term. That means what's happened? I can see my third term is cancelled completely. This means that I will keep cancelling all of the terms. This will be cancelled with the other term if I will list this, and this item will be cancelled with the part of the term if I will list more terms. But I will not cancel this, okay? And I will not cancel this term. That's we can see. If I will kind of start counting the items, 1, 2, 3, 4, 5, and so on, my second and my fourth item is not cancelled. Since it's the telescoping one, I'm assuming that the same pattern will happen backwards. My second item and the fourth one will be not cancelled. That means my green circles are the partial sum. But let's check. Negative, inverse tangent of k, and positive. I'm cancelling this one. Negative and positive. And I also need negative and positive. Excellent. We can see this is my first, second, third term from backside, counting from the backside. Both of the terms are gone, cancelled. This means that this will be cancelled out if I will list more terms, and this will be also cancelled out. But my green circles will be never cancelled out. Okay, as we can see the same pattern. 1, 2, 3, 4. The second and the fourth one. 1, 2, 3, 4. The second and the fourth one. Okay, that's we do have a partial sum. I can list here. The partial sum is negative inverse tangent at 0, inverse tangent at 1, and then plus inverse tangent at k plus 1, and plus inverse tangent at k plus 2. That means this is the partial sum, and I have to think how this quantity behaves, at infinity. That means the sum will be just a limit of partial sum at infinity. So let's think. Tangent for what angle is 0? It's just 0. Tangent for what angle is 1? 4. Now, infinity. How inverse tangent behaves at infinity. We all know is pi over 2, and another infinity, inverse tangent at positive infinity, is pi over 2. However, this is negative, this is positive. We don't really need this. That means this is simply gone. Okay, the answer is negative pi over 4. Interesting, negative. But we may notice that we're subtracting bigger number. I mean, we're subtracting the other way. That's the reason that we got negative. Yes. Okay, that means that's the reason that we got actually a negative answer, because the other terms were cancelled. The positive numbers were cancelled. We end up with the negative. Okay, that means the sum is negative pi over 4. Okay, let's look at my one more example. The same question. Determine whether the series is convergent or divergent. If it is convergent, find its sum. And now we can see we have a summation from 0 to infinity, and the formula is not really showing me the difference. That means it's maybe not easy to recognize, but I definitely see through the two consecutive terms, n plus 1, n plus 2. That means I will do the partial fraction decomposition. Right? This is n plus 1, and this is n plus 2. I know that I can have a fraction a over n plus 1 plus b over n plus 2. Always put addition. Okay, and now I can find a and b. That means if I will multiply n plus 1 times n plus 2 together, I will get the same denominator. But using the coefficients a and b, getting a common denominator, a must be multiplied by n plus 1, n plus 2, and b must be multiplied by n plus 1. That means that's my new numerator, and must be the same like the original one, 1. And now if I substitute instead of n, negative 1, I have 1 on the left hand side, and this will be gone. Negative 1 plus 1 is 0, negative 1 plus 2 is 1, 1 times a, that means a is 1. And if I substitute to my line, to my equation, m equals to negative 2, okay, I still have 1 on the left hand side. Negative 2 plus 2 is 0, a is gone, but negative 2 plus 1 is negative 1 times b, negative b, which means b is negative 1. Okay, that means it works. 1 over n plus 1 minus, because this is negative 1, over n plus 2. Now I definitely see the method of difference. Right, that we can see we did have extra job finding a partial fractions. Okay, let's, since this is the telescoping one, let's find the partial sum. I will list the first term. However, let me write I equals to 0 and ending with k, the finite number, and the formula is I plus 1 minus I plus 2. Okay, let's start listing. If I is 0, we have 1 minus 1/2. If I is 1, we have 1 plus 1, 2, and 1 plus 2, 3. And if I is 2, I have 3 and 4. And I can possibly stop here, and I can list 3 terms from the back side. The last one will be defined at k. 0, let me put this 1, and 2. This one will be defined at k, this one k minus 1, and k minus 2. That's mean 1, k plus 1, k plus 2. K minus 1 plus 1 is just k. K minus 1 plus 2 is k plus 1. And then k minus 2 plus 1 is k minus 1. K minus 2 plus 2 is just k. Okay, let's see what we can cancel out. Negative 1/2, positive 1/2, negative 1/3, positive 1/3. And we can see the second term is gone completely. This means that I will cancel all of the other terms. I will cancel this with the other terms. And what's happened? I only end up with the first item from the first term, which means the same pattern will appear from the back side. The first term from the back side, which is actually the last one. Only this, but let's check. This is gone. Negative, positive is gone. Okay, that means I did cancel everything in the second term. This means that all of the terms will be cancelled. Only the first and the last item. It's kind of like a mirror image, if I will be able to bend it exactly in the middle. Yeah, they kind of like reflect. Okay, that means now my partial sum is defined as a green circles. 1 minus k plus 2. 1 over k plus 2. And now, to get the sum, I have to compute a limit at infinity of the partial sum. This partial sum is shorter. I can rewrite one more time. Okay, that means this one is 1 over big number will go to 0. This infinite series is convergent to 1. Okay. I think I didn't say convergent to negative pi over 4. And this one is divergent, this one is convergent. And this is my last question. Okay, that means now I did solve for you 4 problems. You can solve them again. You can pause the video on every single slide and try to practice. Thank you.